Hello viewers, welcome to Learn C. In this video, I am going to explain the coin change problem using recursion. I am Lalitya Verma. My registration number is 22B01A0583 and guided by Dr. M. Prasad, Associate Professor, Department of CSE, Sri Vishnu Engineering College for Women, Autonomous, Bhimavaram. Our problem statement is coin chain using recursion. Further, we are given an integer array of coins of size m. These represent different demonstrations of currency and we are given an integer sum. We have infinite supply of these coins. That means each coin can be used any number of times. So our aim is to find in how many ways we can make sum using different combination of these coins. Okay. Now let's take an example here. I am taking coin array and 3 coins here. Now the size of this is 3. To make sum is equal to 4. In how many ways we can make combinations using these 3 coins is our actual task. So let us write it here. We can use 4 ones, 2 ones and a 2, 1 and 3 and 2 twos. Okay. Let us understand this better by using a recursion tree. Our sum is 4 and the 3 coins are 1, 2 and 3. In recursion, we have 2 options, that is either to include or exclude a coin. Okay, now to include, or the second one is to exclude a coin. When we include a particular coin, the sum in that means the required sum in the next step would become sum minus the value of that coin, because that coin is already a part of that sum. Let me explain. So here when 1 is included here, the sum becomes 3 and we have 1, 2, 3 demonstrated coins here. That means this 1 is already a part of this sum. So now the required sum becomes 3. When 1 is excluded, the sum is 4 itself. We have 2 and 3 here. So again here when 1 is included, we have our sum 2. And when 1 is excluded, the sum is 3 and we have 2, 3 here. Here also again when 1 is included, we have sum 1 and 1, 2, 3. When 1 is excluded, we have sum 2 and 2, 3. Here also again when the sum is included, that means when 1 is included, the sum is 0 and we have 1, 2, 3. When 1 is not included, we have sum 1 and 2, 3. Here again if we include 1, the 0 sum we cannot make a sum 0, we are using 1 valued coin. So the next cases were not possible. Here if we do the next case, when we include 2 here, now 1 minus 2 is minus 1. So to make a sum minus 1 is not possible. So here the case is not possible. When we exclude 2, we have sum 1 and 3 valued coin here. This case is also not possible because we cannot make sum 1 using a 3 valued coin. So this is also not possible. Again coming to here, when 2 is included here, 2 minus 2 is 0 and we have 2 and 3. When 2 is excluded here, we have sum 2 and a 3 valued coin. This case is also not possible because we cannot make sum 2 using a 3 valued coin. Again coming here, when 2 is included here, 3 minus 2 is 1 and 2 and 3. When 3 is excluded here, when 2 is excluded here, we have sum 3 and 2, only 3 we have. Okay. Again when in this case, when 2 is included here, the sum would become minus 1 and this case is also not possible. When 2 is excluded here, it is 1 of 3 and we cannot make a sum 1 with using 3 valued coins. So this case is also not possible. Here again we have 2 cases, that is to include 3 and to exclude 3. To include 3, if we include 3 minus 3 is 0 and we have 3 here. Okay. And if we exclude 3, we have a null set here. So let me complete this recursion tree and explain later. Now let us see all the possible end cases in this recursion tree. Here the sum is 0. Beyond this we cannot do anything, because if we do sum after 0 we'll get a negative value. That means if we do subtraction, 0 minus 1 is minus 1. So we get a negative value and sum cannot be negative. So this is one of the possible case. Here minus 1, that means sum cannot be negative. So this case is not possible. Here we cannot make sum 1 using a 3 valued coin. So this case is also not possible. Here the sum is 0. We cannot make sum beyond this. So this is one of the possible case. And we cannot make sum 2 using the 3 valued coin. So this case is not possible. And minus 1, this case is also not possible. And here we cannot make sum 1 using a 3 valued coin. This case is also not possible. And 0. This is one of the possible case. And here null set. We have to make a sum 3 without giving any demonstration of the coins. So this case is also not possible. Here again the sum is 0. So this is one of the possible case. We cannot make a sum 2 using a 3 valued coin. So this is not a possible case. This is also not possible. And this is the same as this case. So this is also not possible. And we cannot make 1 using 3 valued coin. So this is also not possible. And here it is null. So this is case also not possible. We have base cases. Base cases are must for recursion. If base cases are not given, then recursion would become an infinite loop. So the possible base cases are, if sum is equal to 0, we have to return 1. That means these cases, these 4 cases. And if sum less than 0 or sum greater than 0 and we have null here, that means we do not have any coins here. And these two, for these both two cases, we have to return 0. Now let us execute our program and discuss there. Now let us start the execution of our program. Here I am taking a function int count and the parameters passed are integer coins array and int I, which is the index, int sum, that is our required sum, and int n, that is the number of coins we are passing. First we have to write the base cases here. Further, if sum is equal to 0, that path is considered as a possible combination, so we have to return 1. If sum less than 0, that case is not possible, so we have to return 0. And the other not possible case is that if sum greater than 0 and index is beyond our size, or if it is null. So for that I am taking if sum greater than 0 and I is equal to n. As it is not possible, we have to return 0. Other than these base cases, here we have to return. In this, I am included with two conditions. That is, when we include a coin and when we exclude a coin. When a coin is included, index remains same and sum is reduced as we discussed. So here I have written sum minus coins of index I. That means the value of the coin which we have included. And here, when a coin is excluded, index is incremented by 1 and sum remains same. Here I am taking another function, that is in main. Now here I am declaring in I sum and n and integer coins array of size, let it be 25. We can take any number here. Now we have to ask for a number of coins. For that I am taking printf number of coins. To store it I am using scanf here. And to store the value of each coin I am using for loop. For I is equal to 0, I less than n, and I less scanf. coins with index I. And now we have to ask for the required sum. That is for that printf enter required sum. And to store that again I am using scanf. And lastly, to get the number of possible combinations, I am writing the number of possible combinations are percentage d count points. Here we have to initialize I to 0 and sum comma n. Now let us run and check the output. Here I'm taking three coins and there are one, two, three, and I'm required a sum of four. So the number of possible combinations are four. Let us take another example. Here I am taking four coins and there are two, five, three, six, and my required sum is 10. Further, the number of possible combinations are 5. This is the end of our program. Thank you.